Alright, in this video we're going to take a look at translating verbal expressions into variable expressions. Now this is an important topic because it helps us understand how to set up and solve application or word problems. And those tend to be very difficult for a lot of students. So let's go ahead and take a look at some examples and see what happens. Alright, example 1, it says 10 less than 7 times a number. A very important key word is the word than. Than is a key indicator word that will tell you to change the order of the terms. What do I mean by that? Well, 10 less than 7 times a number. In the verbal expression, 10 comes first, but because of the word than, we change the order. So that 10 has to go on the end. Now it's a less than problem, so less than means to subtract, and it's less than what? 7 times a number. So how do you say 7 times a number? That's 7x. So the verbal expression 10 less than 7 times a number translates into the algebraic expression 7x minus 10. What about number 2? Twice the sum of a number and 15. Well, the easiest part so far is to talk about the sum of a number and 15. So what does the word sum mean? Sum means to add. So let's go ahead and put the addition down. And we're adding a number and 15. So a number and 15 would be x and 15. So right now we're looking at a sum of a number and 15. Well, the problem says that we need to take twice that. So to take twice that, we have to put a 2 in front and multiply by the whole sum. So this is an important thing here that we're looking at. Anytime you take a product or a multiple of a sum or a difference, the sum or difference has to be inside of parentheses. So again, the verbal expression twice the sum of a number and 15 is written as 2 times the quantity of x plus 15. In number 3, 17 subtracted from 8 times a number. Another important indicator word here is the word from. From is like than in that it changes the order of the terms. So we're looking at the word 17 as being subtracted from 8 times a number. So subtraction, obviously, is a minus. We read 17 first, but because of the word from, we have to move it to the end. And it's subtracted from 8 times a number. So 8 times a number is simply 8x. So the verbal expression, 17 subtracted from 8 times a number, is equivalent to the algebraic expression 8x minus 17. Alright, so let's go ahead and take a look at a few more examples here. In number 4, it says 9 less than 3 times the difference between twice the number and 1. Well, 9 less than, here's the keyword than, and notice 9 comes first as we're reading this, so less than will change the order. Less than means to subtract, so there's the less than portion. The 9 has to move to the end. So what is it less than? It's less than 3 times the difference between twice the number and 1. Well, we know it's 3 times something, and times means to multiply, so 3 times a difference. Remember, when you take a multiple of a sum or difference, the sum or difference has to be inside parentheses. So the word difference here, this time, again means to subtract. So what are we going to subtract here? The difference between twice the number and 1. Well, twice the number means 2x. Subtract 1. So the verbal expression 9 less than 3 times the difference between twice the number and 1 is written algebraically as 3 times the quantity of 2x minus 1 minus 9. All right, let's take a look at number 5. In number 5, it says the total of 6 times the sum of twice a number and 15 and twice the difference between 1 and the number. There's a lot of words going on here, so what you want to do is just kind of take this one slow. Let's start off with the first word being total. Total means to add. So here's my addition. Now, we're going to add 2 things together. The first part of this is going to be 6 times the sum of twice a number and 15. Well, 6 times the sum. Again, we're taking a multiple of a sum or a difference, so that sum this time has to be inside parentheses. So we have 6. Let's try that again. Got 6 times the sum. Well, again, the word sum right here is going to be inside here as plus. Now, twice a number in 15. So twice a number, again, is 2x, and 15 looks like this. So all we've done so far is take care of the first part of the sum, which is this, 6 times the sum of twice a number in 15. So again, the total of that and the next part. Well, the next part is twice the difference. Twice the difference between 1 and the number. Again, twice a difference. That's a multiple of a difference, so that difference has to be inside parentheses. Difference means to subtract, and it's the difference between 1 and the number, so it's 1 and x. Notice it has to be 1 and x. It could not be x minus 1. There's no than or from that would indicate to change the order of the terms. So when it's the difference and we read it, it's the numbers or the terms appear in the order in which they're read. So the verbal expression in example 5 algebraically is written as we have here. Next, we have number 6. This actually comes up quite often. The sum of two numbers is 54. If x represents the smaller number, translate 3 times the larger number. Well, 54 is a total in the problem. It's the sum of two numbers. So what we're going to do is just make a list and write the items that they're talking about. In this problem, they're talking about a smaller number and a larger number. And they tell us in the problem that if x represents the smaller number, so the smaller number is x, they want us to translate 3 times the larger number. Well, what is the larger number? That's really the question, first of all. Well, when the total is given, what we do is x is one of the numbers, and the total minus x has to be the other. Now, the reason for that is because of the first sentence in the problem, it says the sum of two numbers. So if I take the smaller plus the larger, I have to get the total, and that's 54, which again is given in the problem. So if x is the first number, what can I add to x to give us back 54? Well, I'm telling you it has to be 54 minus x, and let's see what happens when we put 54 minus x. Combining the like terms on the left-hand side, the smaller number is x, the larger number has a minus in front of its x. So those two x's will cancel each other out and leave you with 54 as the sum is supposed to be, as was given in the problem. So, again, if the total is ever given in the problem, let one of the items be x, and the other one has to be the total minus the x. So now we know that the larger number is expressed as 54 minus x. Now we can translate 3 times the larger number. So how do you say 3 times 54 minus x? It's pretty simple. 3, using parentheses, we put the 54 minus x like this. So the answer is 3 times the quantity of 54 minus x. All right, let's take a look at one more example, number 7. And there's a lot going on in this one, so you might want to pause this video and restart it, to kind of help you get a feel for what the problem is asking. All right, let's take a look at the first sentence. It says the sum of two numbers is 40. So the sum, that total is given in the problem. And remember, when that happens, what we're going to do is let one thing in the list be x, and the other is going to be the total minus the x. So we have a smaller and we have a larger number. Well, in this problem, it tells us that they want us to use x to represent the larger number. So x is the larger number. So the other number has to be the total minus the x. So now that we have this set up, let's see if we can translate the verbal part of this expression. The difference between 9 less than the smaller number and twice the larger number. So let's go ahead and start here with the difference. We know what the difference means. Difference means to subtract. So let's go ahead and write the subtraction down here. Now, when they say difference, they're talking about two different things. So let's go ahead and try to coordinate this with coloration here. It's the difference between what? 9 less than the smaller number. So that's going to go down here. So 9 less than the smaller number. And then on the other part over here, we're going to put twice and twice the larger number. So that's going to go over here. Again, it's just a lot of stuff, and we're trying to break this down slowly if we can. So we already have the difference here. So in the green area over here, let's go ahead and see if we can translate 9 less than the smaller number. Well, the smaller number is here. It's 40 minus x. So how do you say 9 less than that? 9 less than 40 minus x. Remember, we're reading the number 9 first, so it has to come last in this little green region down here. So 9 less than 40 minus x is going to be 40 minus x minus 9. Now in the orange area, it says it's the difference between that and twice the larger number. Well, twice the larger number is 2x. Twice the larger number is x, so twice that is 2x. So what we want to do now, the second part of this, the instructions here says, then simplify the expression. So what we want to do now is just kind of simplify the expression 40 minus x minus 9 minus 2x. The parentheses that we have here really aren't that important, so what we can do is just drop those. So that gives us 40 minus x minus 9 minus 2x. Combining like terms, I'm going to put these variable terms together first. We have a minus x and a minus 2x. That's minus 3x, or negative 3x. Then we have a positive 40 with a minus 9. That gives us a plus 31. So the simplified expression then is going to be negative 3x plus 31. I know this is a long video, but this is really an important topic to understand how to set up and solve application problems. So I hope these keywords are helping you understand how to put things together, and my explanation as well. So anyway, take care.